Non-disjunction is an event where chromosomes or sister chromatids fail to separate. So we're really talking about the failure during anaphase, that they're not separating appropriately. This is going to produce gametes with an abnormal number of chromosomes. In fact, non-disjunction, I do want to point out, occurs quite frequently, more frequently than you think it does. And because of this genetic material now becoming abnormal, I'll use my little pointer here and I can see non-disjunction in meiosis 1. Homologous pairs of chromosomes are not going to their pole, their respective pole of the cell. They're actually both going to a similar pole. And so we're actually going to have the non-having of this genetic material, and the gametes are going to have an overall extra chromosome, that's N+1, or a loss of a chromosome, that's N-1. These are abnormal gametes. During meiosis 2, so now we're splitting sister chromatids, we can actually have those sister chromatids not splitting, and we get an extra chromosome at the end, N+1, or missing a chromosome altogether. We can also get normal gametes during non-disjunction in meiosis 2. Appreciate that in meiosis 1, all the gametes that form, all those daughter cells, are abnormal, whereas if you have non-disjunction in meiosis 2, you have some abnormal gametes, you have some normal gametes as well. And so going back, non-disjunction appears to be involved in 10 to 30% of human conceptions, so that's actually a large number. It's the main reason for pregnancy loss. A lot of times women miscarry quite early on in the pregnancy. Sometimes they didn't even know that they were pregnant when this happens. And this has to do with the body rejecting this organism, zygotes, now because of this abnormality, extra or loss of genetic material. Otherwise, that organism is not going to be carried to term. So this is actually a large portion of miscarriages that end in this way. This is not always the case. So this is another image showing you guys gametes with those extra sets of chromosome. It looks like non-disjunction occurred in the mother here, because here's an egg gamete with an extra chromosome. We symbolize that by saying N+1 because it's not truly haploid. It's got that extra chromosome. That occurred during meiosis because of non-disjunction, incorrect splitting. And here we have a normal sperm. So I'm just going to represent that with the haploid number N. And there's the abnormal zygote that forms with those abnormal number of chromosomes. So it's a diploid number since it's a zygote, but we have that extra chromosome that we got from non-disjunction that occurred in the mother gamete.